Greetings, everybody. Alright, section 14.4 video for you. It's about linear motion, which we've studied quite a lot of in chapter 7 and in chapter 9 so far this year. And then it's also going to include trigonometry, which we have only included in chapter 14, of course. So, like the rest of this chapter, all the new stuff that we're throwing in is just the fact that it's trigonometry based. What we're going to do in this video is we're going to solve problems about particles whose motion is modeled by a trigonometric function. We're going to do one of those here. It's going to be an IB style question. And then I'll also go over a few of the key principles for these linear motion or kinematic problems, as they're called, that you need to be aware of. And let's make sure we do that first, actually. This is summarizing what we've learned so far about these various things. All right, and the first thing I want to do is make sure you know how you get from displacement to velocity to acceleration and so forth, right? And you know that if you're going down this list from displacement to velocity to acceleration, you're using derivatives. So this would be a sequence that you are very familiar with, I believe. The velocity is the derivative of the displacement function, and then acceleration is the derivative of velocity. And of course, if we're going backwards, then velocity is the integral of acceleration, and displacement is the integral of velocity, or the antiderivative of velocity. All right, that you should be familiar with. Again, this is just a concept summary here. And a few other things I want you to be aware of as a concept summary. Now, a lot of this I know you know, and some of it you may not remember quite so well, so this is a good list here. First of all, I want to make sure you know what it means if you're finding S of 0, V of 0, or A of 0. And those are all simply just initial values. Either initial displacement, initial velocity, or initial acceleration. Okay? And then it means something in particular when the velocity is equal to 0. Whenever the velocity is equal to 0, it means a particle is at rest. Which we use that one quite a lot. What we haven't used so much this year is when the acceleration is equal to 0. Those of you in physics have used this quite a lot. If acceleration is equal to 0, it means that there's a constant velocity. And then what if the velocity is equal to something other than 0? Well, if it's greater than 0, the particle is moving right. If it's less than 0, the particle is moving left. And that can be, of course, up or down depending on the context of the problem. Now that one we've talked about before. Acceleration, if it's positive or negative, we haven't talked about that. But there's a direction for the acceleration as well. And so if the acceleration is positive, it's accelerating to the right, or it's accelerating to the left when it's... Alright, and then the last couple of things I want to talk about is what if the sign of the velocity and the sign of the acceleration are the same, and what if they're not the same? Meaning one's positive, one's negative here, or they're both positive or they're both negative here. Well, anytime the velocity and the acceleration both have the same sign, it means the particle is speeding up. And then whenever the velocity and the acceleration have different signs, the particle is slowing down. It's kind of like you're walking forward on a treadmill, but the treadmill is going the opposite way as you. All right, so you'd say it slows you down. There we go. Those are the key concepts. And there's a couple of equations I want to summarize for you here, and then we'll get into the problem that we're going to work on. Remember, there are a couple of formulas that we learned in chapter 9. If you want to find the change in displacement over time for a particle in motion, you can integrate velocity. That will look like this. All right, the integral of the velocity with respect to time. And then if you want to find the total distance, you can find the integral of the absolute value of the velocity function. Alright, well, there you go. That's just a bunch of review stuff for the most part. Let's get into the problem. And I said this is an IB problem from the test bank. It says here that the acceleration, a meters per second squared, of a particle at time t seconds is given by a equals 2t plus cosine t. So there's us with a particle in motion, and the motion is represented by a trigonometric equation. The first thing it wants us to do is to find the acceleration at t equals 0. Alright, now throughout this whole video, if you know how to do a problem, I'd prefer that you go ahead and try it on your own and then watch me. So if that's you, pause the video now, come back and listen later. First part of this process is that we got to recognize which function we're given. We're given a function for acceleration, and now we're asked to find the acceleration at t equals 0. That means we're asked to find the initial acceleration. But very simple, right? We're just going to go ahead and plug in 0 for for t. So that'll give us 2 times 0 plus the cosine of 0. Now 2 times 0, of course, is 0. The cosine of 0 is 1. And so that tells us that the initial acceleration, when t is equal to 0, is 1 meter per second squared. And make sure you include your units there. This is one of those where you get a unit penalty if you don't include it. Good so far? All right, remember that equation. Well, it's on your paper. I guess I'm the one that needs to remember that because it's going to disappear from my screen. All right, part B. It says find the velocity v at time t given that the initial velocity of the particle is 2 meters per second. All right, well, the first part of this is we got to know how we get from what we know, which is an acceleration function, this, to velocity. And this is what we said at the beginning of the video. If you're going from acceleration to velocity, you're finding the antiderivative of the acceleration. So the v is going to be equal to the integral of a. All right, so go ahead and integrate a if you know how. I'm simply dividing my integral up, so I'm integrating each term separately. And so let's see. We'll get t squared plus the sine of t plus c. All right, now we didn't know the constant of integration, but that's why they told us what the initial velocity of the particle is. All right, what we can do now is we can set this equation equal to 2 for when t is equal to 0. You already know how to do this, but watch. There you go. When time is 0, the velocity is 2. Plug that in over here. All right, 0 squared is 0. The sine of 0 is 0. So it turns out that c is equal to 2. And what that tells us then is that, of course, fix that right there, the constant of integration was 2. And so our velocity function in terms of t is t squared plus sine t plus 2. Still with me, I presume. All right, 2 more parts to this question. The next part says find the integral from 0 to 3 of the velocity function, giving your answer in the form p minus q cosine 3. Now we'll have to talk about this form thing in a moment, but you know how to find this integral, and so let's go ahead and start that. Take the function that we just made, and I haven't written each term separately, but I'm still going to integrate separately, so here's what we'll get. All right, the integral of t squared is 1/3 t cubed. The integral of sine t is negative cosine t, and the integral of 2 is 2t. And then we're going to plug in our limits of integration. We're going from when time equals 0 to time equals 3. Remember, you do that where you plug in the first one, and then you subtract the value of the second one being plugged in. So that'll look this way. All right, this first part is me plugging in 3 into the function. Then I'm going to subtract when I plug in 0. And every bit of this that we actually need to simplify is mental math. All right, 1/3 of 3 cubed means 1/3 of 27, so that's 9. And then we're going to have a plus 6 out here, so that we're going to get 15 minus cosine 3. Remember that our answer wanted us to have something cosine 3 there? Well, there's our cosine 3 right here, so that's kind of nice. And then we're going to subtract. I don't know why I put an equal sign. We're going to subtract 0 minus the cosine of 0 plus 0. Alright, so these two terms go away. The cosine of 0 is 1 though, so we have minus negative 1. And then finally, that's going to leave us with 15 minus negative 1 is 16. 16 minus cosine 3. So that's in this form right here. The P is 16. The Q is -1. Excellent. So that would be, well, I'm going to talk about what that represents here in a moment. That's the next question here. Hopefully we're good to this point. One more part to this question. And what it's going to do is see if you understand the meaning of what you just found right here. Question asks, what information does the answer to C give about the motion of the particle? What information does the answer to C give about the motion of the particle? Well, I'm going to go back to something we talked about earlier. Remember that when you integrate the velocity function, it represents the change in displacement of a particle between two different time values. And so that's exactly what it meant for us here. The integral of the velocity function from 0 to 3 tells us the change in displacement from the initial time until 3 seconds later. And that's what I'm going to write here. By the way, that means that this answer would be in meters, right? Because displacement is always going to be in meters or centimeters. It's going to be a distance. Here's how we'll write the answer to this question. The integral from 0 to 3 of the velocity function, d of t, or with respect to t, is the change in displacement of the particle during the first 3 seconds it was in motion. There you have it. There's an example of linear motion that is modeled by a trigonometric function. Thanks for watching.